Hello, welcome back to Mini Rust in Rust series. This is video 25. We are working from an example, a motivating example that we would like to make work, which is a little bit of a calculation of Fibonacci by looping through, multiplying x by I every time, increasing I by 1, and when I gets too big, then we stop and return x. So that's just, I don't mean Fibonacci, I mean factorial. I wonder how many times I said that in the last video. Maybe none. Anyway, this is calculating factorial. That doesn't matter. What matters is it's a little bit of code with a loop in it and stuff like that. And the first thing that went wrong is that we weren't able to lex our less than or equal sign. Last video we made that work, and if we run this test now, I think we'll find we're not able to parse a less than or equal sign. Maybe, we'll see. Okay, oh no, the next thing is this curly bracket. So yeah, more lexing to do. So let's do some more lexing in this video. So let's lex the opening and the closing curly bracket, shall we, just for fun. And that's going to cause all kinds of parsing trouble later, but we won't worry about that yet. So let's have another test of parsing stuff. Maybe just parsing those characters on their own would be enough. Let's try. So let's just try. After these ints, after then floating points, before the kind of multiple token stuff, let's just lex curly braces. Should we just call them braces? Let's just call them braces. So when I lex a curly brace, or a brace, then it should give me back a token of a specific type. And I think we want the type of that thing to be its own thing. So I think we want to call it brace close, maybe. Oh, I mean, sorry, brace open, obviously. Like so. And similarly for the closing. Now that might be, we might decide that all braces and all types of like brackets should get their own, should all be contained in one type of thing. But we'll start off doing it like this and see how it goes. So if we have a look at these functions where we create stuff, we had one for all operators, you see, so they're all kind of lumped together, but braces and parentheses and things are so special that I think maybe we want separate ones. Like colon, we've given its own separate one. Semicolon, yeah. So let's just go after semicolon. Let's do brace open and brace close. So brace open, brace close, and all this other stuff is the same, except this. This feels like there must be a better way of doing this, but it would probably involve macros, and I don't want to write macros, so we won't do it. So and brace close comes first because it's alphabetical. It is alphabetical, right? No, it's not alphabetical. Alright, let's put it in the same order we put it in the functions. Oh, we can't because they're different. Oh, why have we made a mess? Let's just put them at the end after semicolon. That's kind of consistent. Yeah, we have this to do about saying, do we actually need these strings? Probably not. But for now, we're not changing that now. Okay, so where are we at? This code is complaining that we don't handle these two types of things. This is in a parser. Yeah, we've got two new types of token. And we should just to do them for now. because we're not doing parsing yet. Why did everything move? Right, what else are we moaning about? We haven't actually done brace close and brace open. That's okay. That's all fine. So let's run our test. That's what we should do. Right, so it's complaining. So our example is failing, and also our new test that we've written is failing. So let's disable our example. Again. Should have one test failure now. Nice and simple to fix, which is we should be able to lex braces. And these are ultra simple. So let's look at our lexing code. And braces are always just one character, at least for now. I think always. So we're going to treat them exactly the same way as this really simple stuff like semicolon. And again, let's put our stuff immediately after semicolon for consistency. And we're going to have two separate cases for open brace and close brace. Like this. I put the word brace first because it groups together like in some alphabetical ordering, or just first, like hierarchy of like the first word you come to is a higher level in the hierarchy. That opening and closing braces are they're the same type of thing, right? And that's what I've done. I just realised I ordered these differently, so let's put those in the same order because it's just not alphabetical order here. Okay, so anything else? I think these look the same. Is that it? Is it going to pass? Yeah, except I messed up one of my tests, right? Yeah, brace close should have a closing brace in it. Again, that string doesn't seem necessary. Okay, so we're able to lex braces. So let's continue trying to lex our example and see what happens next. Okay, we need to support times equals. Can we avoid that? We can avoid that for now by doing x equals x times I, which should be already lexible. Hopefully already evaluatable if we're really lucky. Oh no, we haven't done times or times equal. If we do times, then parsing it and evaluating it's going to be super easy because it's just like plus. So let's leave our code like this, but make it lex the star symbol as well. So another test for that. It's going to look very similar. Let's do a multiplication expression, shall we? Just to make it a little bit more challenging for, like, us, make it less likely that we'll make some mistake. That means that times signs can only work on their own or something like that. So let's make this 2 times 150, and let's do a 1 without spaces just to satisfy my fears. So it's going to come out as 2 times 150. So the reason why operators make sense to be all the same type of lexing token, all the same type of parsing thing as well, is that they're really, really similar, whereas opening brace and closing brace are really, really different. So I think this makes sense. Alright, so now we should have a failure. Let's turn off the example again. No, like this. Now we should have just a failing test in our lexing code, yep. And now we can make our lexing code work by finding our main lexing match statement and saying, look, times is also an operator. Maybe there's a good way of doing an OR that isn't just like this. We'll see. So is that it? I think that's it. We just say times is an operator. Oh, no, we need to go in here and say I'm not enjoying this, but this is going to get fixed when we... I tell you what, it's getting more and more interesting. This should be char 1. It's getting more and more interesting of like how we're going to support all the operators instead of just a couple. So I'm starting to think we won't do that in the background. We'll actually do that as one of our videos, maybe one coming up quite soon, because filling out a bit of stuff so you have an actual set of useful operators and numbers and stuff feels like an important part of a real language. I'm trying to make it useful for actual stuff. So anyway, that was waffle, wasn't it? So star can never be followed by another character, so our error handling for that will automatically fall out. We are now able to lex. So let's put our example back again. Let's see what goes wrong next. Okay, so our let statements as they stand so far do not support putting mute as a keyword. It actually thinks that mute is our variable name, and so it's expecting an equals sign to come after mute. It would be nice if that error said expected an equals sign, wouldn't it? Let's look at the code and see whether that would be the kind of, like how we might do that. But let's not lose focus on the fact that we need to support mute as a possibility here. So, this is a parsing error. So everything lexed. Our whole example now lexes, which is nice, isn't it? But obviously it's stuff we can't parse, like these braces, which are going to be really tricky. But the first thing that we need to be able to parse is this mute. And I think we can do that in this video, and we'll probably have to stop there. So let's have a look at our parsing code. And when it's found a let, well, okay, first things first, we need a test for this. So let's write a test. So let's write a test that matches exactly the case we've got, which is something like this. And we'll also need to make sure that it handles things with types included and stuff like that. So let's say something like that. Then it is going to be an assignment. The symbol is going to be X. Sorry, not going to be X. It's going to be PP, which is going to start from 1, 2, 3, 4, 5, 6, 7, 8, 9. I think. I don't know if it starts at 0 or not. I think it starts at 0. I think it might be 8. And it's too long. And the right-hand side is going to be, how many characters are 1, 2, 3, 4, 5 characters on, if I counted that right, and length 2. And it should be called parse mutable assignment. And we also need a way of saying this assignment is mutable. So let's have a look at what syntax tree currently supports. It's a syntax node. Syntax node has this thing called operation, and operation has a potentially declared type, and it has a symbol and expression, and it also needs to have something called mutable, which is a boolean. And that's going to break loads of code because all our existing code doesn't know about it. So we need to pass in that boolean here. I think it's as simple as that. Where else does this go wrong? And there's lots of places where we are calling assignment. And so for now, they're all just going to say it's not mutable. This one should be false. I was wondering if that's the right place, but it is. This one should be true. This is our new one. I want a comma at the end here. I didn't have one before, but I want one. Okay, this one should be false. Where's the end of assignment? Let's percent on that. Did I do it wrong? I did it wrong. It should be in here. I really done it wrong now. This thing popping up in front of me absolutely destroys me. It should be here, obviously, and not here. Right. Where else? This one. Also, no mute in that. So we know whether it's false or true, by the way, just by looking at here. Does it say let mute or not, right? And not the ones we created already are not mutable because they don't have mute. So we just pass in false here. That's all I'm doing. Okay. We should mention it here when we're matching. And for now, we're going to ignore it. So that means we have to ignore it. It's a slightly annoying thing. We have to do that. This should have mutable, which means we need to pass it in here. I'm wondering what the thing was I did a minute ago, but yeah, okay. So, where are we? This is when we're type checking. So the information about the assignment should have got passed into us, so we should pass it on. I think that's the way this is going to work. And when we're type checking an assignment, we need to pass in whether or not it's mutable. Oh, so now this is no longer unused. That's good, isn't it? Here we are testing. So we just need to say false because this is not a mutable assignment. Same again. And same again. So what we've done is added this property of mutable to all the assignment things in syntax tree. And then we've said that we've written one test that says it should say that it's mutable in our test. Let's disable our example. That's not how you spell ignore. Let's disable our example. We should still have one failing test. It should be failing for the same reason. But we've changed our assertion now to say you should have taken into account this mute when you did it. But our parsing of assignments is still not taking into account the fact that there could be a mute in there. So how do we do this? We either find let and we go to the assignment statement, or we find something else. So in our case, we found a let. Now we look for an equals or a colon. And it's no longer an equals or a colon. It could now be an equals or a colon or a mute, right? So let's try that again. So we're checking for, is it a colon or is it an equals sign or something else? And the other thing it could be is a symbol. Do we have a difference between symbols and keywords? What did we do for let? Oh yeah, it's not a symbol, it's a keyword. It should be a keyword. It should look like this. Let's just copy this stuff. So we actually need to make mute into a keyword. Makes sense? So it should look like this. And what we're going to do, if we find mute, we're going to need to do this again. All right, let's just put a to-do in for now. Because already mute doesn't exist. Oh, that's the wrong type of arrow. Mute doesn't exist yet, so let's make that work first. We've got to think about the fact that, yeah, I'm not sure this was the right thing to do. We should probably handle it being mute early and then fetch another token. But anyway, let's worry about that in a second. So let's add ourselves a variant called mute. Let's have a look at where I added it. So at the moment we only have let and mute. They're in alphabetical order. Those are the only two possible keywords. Have we broken anything else that matches on keyword? No. All right, so that means we're able to be very, very explicit about if this token was a mute, then match on it, not just any symbol or whatever, or any keyword. So that's nice. All right, so we've got a warning saying mute is never constructed. That's okay. That will be dealt with in a second. And we've got the same failure, which is that although we pick up this mute, hold on. We don't pick up this mute. I was expecting to hit this to do of like we hit the keyword mute, but we're not. So I guess the question is, when we're lexing, we need to lex. Yeah, we need to lex here. So I've seen where we need to fix the code, but let's not fix it yet. Let's first of all write a test. Where's our test for let? We can say, let's just say lex some keywords. Right, and we'll add another test for if you find a mute. In fact, let's do let mute. Let's be a little bit smart about it. This should come out as two things now, right? It should come out as a let and then a mute. Yeah, all these strings in these tokens are just not needed. So this should be from about character number 4 for 3 characters. So hopefully that'll work. I've got a warning on line 231. Yeah, I mean, it's not constructed. That's fine. So now that test that we've just added should fail. Yeah. So we're supposed to be getting let. We're supposed to be getting a keyword called let and then a keyword called mute, and instead we're getting a keyword called let and then a symbol called mute, and that's because our lexer doesn't yet recognize mute. So where is our lexing code for that? Oh, we're not in our lexer, that's what's going on here. Yeah, here. So it's very, very simple the way we're handling keywords. Before we look for symbols, before we consider something is probably a symbol, we just check whether it's a keyword, and if so, return. Let's just look at where we call that code just for context. Yeah, so if it's a keyword, then return a keyword. Otherwise, it's a symbol. This is essentially our logic. All right, so how's that going to go? It's going to fail in parsing because we weren't expecting a mute. But I thought we were. I wonder how that happened. Let's have a look at where we got to in our parser. We ended up... Oh, that's no use. That line number's no use to us. Let's just look at our parsing of an assignment. So it's found a let. And I was expecting us to get to here. So let's just print out what this thing is. You're probably screaming at the screen saying, I've figured out what you've done wrong already. Okay, so it looks to me like it didn't get to that code. Oh, because I am wrong. I've done this completely wrong. Fine. Good. Okay, so what happened was we expected to find a symbol here. That's what this token of type thing does, right? It returns a token of the expected type. And we're expecting that type to be symbol, but now it's possible it could be a keyword or a symbol. So we actually need to say let symbol or mute equals self dot token. We have to pass in that previous token span. So now it's either a symbol or a mute, or it's something else. So we need to match on that and say if it's a symbol, so I guess it should be it's either going to be a symbol. Oh, this should be match on its kind. That's what we did in the that's what we did in the later code. So it's going to be a token kind symbol with whatever stuff lives inside it. I guess that should be like name or something. I mean, it actually doesn't matter. It's just we want to return this whole thing. So we could do this. Have you seen this before? Have I even done it right? I don't know. I think so. Yeah. So far it looks right. So I'll explain that. If I'm actually right about how you do that, then I'll talk more about it. I'm a bit worried I've got it wrong, so I don't want to try and explain it and then be like, oh, actually I'm completely wrong. Anyway, so previously we got hold of symbol by saying it must be a symbol, just give it to me. Now we're saying it's either a symbol, in which case you can have it, or it's a keyword, or I guess we need to fail some way. Tofu. To do that in a second. But if it is a keyword, what we should do is fetch the next thing, and this time it definitely will be a symbol because the only thing allowed was mute. So if we found a mute, then symbol is that, but also whether or not it's mutable needs to get set. So we need to say the symbol and whether it's mutable is getting set up by this stuff. If we just found a symbol, then it's not mutable, so we return false. If we found mute first, then it's mutable, so we return true. Don't need that semicolon. Now symbol doesn't need defining here. This thing is wrong. This was totally wrong. So this cannot be a keyword. And if something goes wrong, instead of that to do, we can actually just say it's unexpected token. And the thing that was unexpected token was symbol or mute. Maybe this should live in its own function, I'm not sure. Now what's it moaning about? Oh, that should be, I think we need curly brackets around that. It's complaining about token of type. Because I've got the wrong number of brackets? No. Why can't I call token of type here? Oh, well, hold on. There's an extra curly bracket, right? Oh, no, the formatter added that curly bracket in. Yeah. Okay, it's complaining because we're trying to turn something into a token when it's expecting it to be a token kind. Oh, that's because I'm completely wrong here. Completely wrong. If it's a symbol, we don't return S, we return symbol or mute. So I didn't need that at thing. So the at thing was saying, grab this whole thing, including token kind, colon, symbol, and put it into this variable, which I was calling S. At means just give me this stuff, put it into this variable. But I didn't want a token kind. I wanted a token, and the token is called symbol or mute. So, don't need that. Get rid of the extra underscore mutes that I had accidentally added in here. Yeah. So my mistake initially was to think that the mute came after the variable name, which obviously it doesn't. It comes first. So what we need to do, instead of just grabbing a symbol, which we know is going to be a symbol, instead we grab the next token. It's either a symbol or a keyword, or there's an error. If it's a symbol, we just return it and say, nope, it's not mutable. If it's a keyword, we say, if it's a keyword that is specifically mute, then we say, grab me the next thing, which must be a symbol, and say that it's mutable. So with any luck, we're close to the correct solution here. Symbol was actually a token kind before, is that right? No. I'm looking at the wrong place. So symbol has type token, whereas in the assignment statement, we're expecting a symbol token. Okay. So, this returns, or whatever type we're expecting. I see. So I think I want this to be a symbol token. Maybe I can figure that out. Symbol token, comma, bool. So now symbol or mute is not right. Because it's just this thing is just a token. Whereas this token of type returns a symbol token by calling check token of type. So I think we can call check token of type. I think. Let's try it. No, hold on. Let me look at that one more time. We call self.token of type. It calls self.check token of type. Yeah. So I think we can just do self.check token of type here. Symbol or mute. I feel like we're doing the work twice here. Yeah, we're doing the work twice here because symbol token colon. What is a symbol token? That needs a question mark for sure. I think this is the type checking. No, it's not type checking. All right, we're going to use mutable in a second. Stop moaning. All right, so what does check token of type really do? It takes in a token and it returns something that you can try to make from a token. And it tries to make it, and if it succeeds, okay, all right. What this is, I'm remembering now, is we have these various enums. Where are they? Like symbol token, which are things that are known to be tokens that are actually symbols, and it means that in the rest of our parsing, we don't have to check again, is this a symbol token or not? So it's actually representing something that is still, I think it's still a token. Oh man, I'm losing my confidence. I'm pretty sure it's still a token, but it's just that we know what type it is. So we're kind of locking that type knowledge into it. Not type as in the type within the program language, the type within our stuff. So basically, check token of type is basically make sure that this is a symbol and fail. Otherwise, we actually already know it's a symbol. But we know by calling its kind and not by doing the try from, which is what's needed here to make this symbol token. So I'm going to get rid of the colon stuff here because it's now just known, right? No, you need it because check token of type needs to be told what type it's expecting. So this is a bit of a mess, isn't it? But anyway, I think it's okay. It's a fairly short little chunk we've added at the beginning of assignment, which says if it's mutable, then if you find the mutable keyword, then it's mutable. Now we've got this thing called mutable, which we need to do something with here, because we were hard coding that it wasn't mutable before. So now our test should pass. Yes, it does. Amazing. Let's have a look at our example and see how far our example gets. Don't think our example will pass yet, because it's going to fail on... Yeah, it doesn't know what while means for a start. So while needs to be a keyword. So I guess next time we're going to parse at least some of a while loop. And yeah, then we'll get to a nested stuff within the curly braces, maybe, if we're lucky. So hope you enjoyed. We got to the point of, let's put that back. We got to the point where we can lex all of this. That was how we were before. But now we can parse these things, and we know that they're supposed to be mutable. We've recorded that information. We haven't actually really used it for anything. And it'll be really interesting to use the fact that something's mutable or not mutable to check whether we're allowed to do stuff with it. So that will be something we will eventually get to. Definitely not to make this example work, because we're just following the happy path for this example. But yeah, the next thing is to do parse trees that get a little bit more nested, because a while loop can contain statements itself. So that should be fun. See you then.